Good morning, everybody. My name is Erika Soriano Castillo. Actually, I studied the second semester of the high school and I stay in the group A. Today, I will show you and explain how to solve a problem of point solve form with my team that is Darren Taylor Flores.
The problem that is in the screen is this. The force applied to a spring and the extension of the spring are connected by a linear relationship. When a spring holds no mass, its extension is zero. When a force of 160 newtons is applied, the extension of the spring is 5 centimeters. What do we have to define? 1. Find a linear model for the extension of the spring in terms of the force applied. Make sure you state clearly the variables you use to represent each quantity. Second, find the extension to a spring when a force of 370 newtons is applied. First, we will begin to explain the concepts and the problem. It asks us to find two things: a linear model for the extension of the spring in terms of the applied force and the extension of the spring when the force of 370 newtons is applied. Secondly, we will divide the given information. What the problem says is that the spring begins without mass and without force, and in coordinates we could take it as 0, 0. But then a force of 160 newtons is applied and the extension changed to 5 centimeters. The shape of the charge will be 160, 5. Thanks that we already have the information in chart, we can transfer it in a graph. Thirdly, we will find the slope to solve the problem using the slope equation, rise and run. The result is 0.03125. To find the linear model of this problem, we have to use this equation and substitute these quantities, because the first state spring is 0 in force and mass. The substitute variables will also be 0. So we get this equation. Y is equal to 0.03125x. This will be our formula. The formula means that for every newton we apply, the spring we obtain is 0.03125 centimeters. With this information, we can solve the whole problem.
Almost finished. The problem asks you to find the measurement in centimeters of the spring when a force of 370 is applied. We will start by substituting the information. E is equal to the extension that it is 5 centimeters. F is equal to the force that it is 160 newtons. And M is equal to mass that will be equal 5 centimeters. We will multiply 5 by 170 and then we will divide this result by 160. That gives us a result of 11.56. This means that if we apply a force of 370 newtons in the spring, it will have an extension of 11.56 centimeters. Finishing off, a single question remains to be answered. Could you use your linear model to model spring compression? Yes, if we can measure the distance while the spring is decreasing in size, we can notice how the force decreases. We can express the problem with the formula G is equal minus mx. The result of the force, or the mass, of the springs will be negative, which means they are both decreasing for spring compression. What will be our conclusion? As well, in our opinions, this theme is more important because it helps us to know how to calculate with the formulas the distance that a spring extends with the application of a certain force. bearing in mind that we must have certain data which are the first that it expresses and the distance that the spring travels with stretching. Finally, with the data that we wanted to know, we can make the linear model representing the data.